In this video, I'm going to show you how to find all of the solutions in an infinite solution system. And that means finding all of the points along that line intersection of two planes rather than three. To do this method, we need to use a little bit of algebra. However, the steps that I'm going to show you are quite straightforward to follow. This is our system, and we're going to verify first that this is actually an infinite solution system. So we can see that by doubling the second equation and changing all of my coefficients, that I can actually add the first two equations together to get the third. So that means that in three-dimensional space, that third plane there is completely unnecessary. So really we only have two planes, and two planes must of course intersect along a line, giving infinitely many solutions. Now, the rest of this video concerns how to find those solutions. First step, ignore one of those equations. I've chosen to ignore equation 3, but you could have just as easily chosen to ignore equation 1 or 2. Our goal here is to create three equations, one for x, one for y, one for z. All of these equations are going to be in terms of the fourth variable, t, and that means that they are all parametric equations. And I can change the value of t to give me new solutions for x, y, and z. So I could change it infinitely many times to find all of the infinite solutions. The first equation is quite easy to find. All you do is write z equals t. And then you swap out z over here for t in each of my equations. Unfortunately, the other two equations are a little bit harder to find. To find the equation for x, I'm going to write my two remaining equations over here. Remember to use t instead of z. I'm now going to try and cancel out the y coefficients by making them equal. That means I need to triple the second equation. So I'm going to change my coefficients now. Make sure you do it for all of them, and also for the constant term. Now that my coefficients for y are equal, I can subtract the two equations together to create a new one that doesn't have y in it at all. It only has x and t. I'm going to subtract the first equation from the second to leave me with positive terms. So y cancels out, and I'm left with 2x plus 11t equals 5. I can then rearrange this to get an equation for x in terms of t. So I get 2x equals 5 minus 11t. Then dividing by 2, I get x equals 5 minus 11t over 2, which I can write up here in my solution set. We've done our equation for x. Let's repeat a very similar process for the equation for y. All we have to do now is cancel out the x terms. So let's rewrite those two original equations over here. Remember to use t again. I'm going to use my unmodified second equation to start with. This time I'm going to try and cancel out x, so I'll need to double the second equation. So let's change those coefficients now. And I will subtract them again. So the x's cancel out. I'll subtract the second equation from the first, and I get y minus 7t equals negative 3. I can then rearrange that to get 7t minus 3, which I can put up here in my solution set. I now have all three equations for x, y, and z in terms of t. So what I can do is substitute in values for t in order to get my new solutions. So the easiest one to do will be t equals 0. Plugging that in gives me 5 over 2, or 2.5. That's negative 3, and that's 0. That is one of the infinitely many solutions to this problem. Another one is, for example, t equals 1. But actually, I could use any value for t. This one will give me negative 3, 4, and 1. And that's how we do it. Thanks for watching.